Okay, hey everybody. I've improvised a little handheld tripod um, for my iPad, which has a little clearer video than my old iPhone. Um, so we're gonna look at some rocks. So I've got an outcrop behind us here on this structural geology field trip, and you can see that it is intensely folded. And now we're gonna go investigate what type of rock it is. Now I already know that it's Jurassic Carmel Formation, and that formation was deposited in an inland seaway during a very arid time. So there's some clues for you. And now I will walk backwards and approach it. You can see down here, got some of the tools of the trade arrayed. We've got a rock hammer for scale, sort of. There's a little knife and a bottle of acid. So let's do some tests on this rock to see what it is and why it's deforming so easily in a ductile fashion. So, unfortunately, I don't think my tripod is going to stand its own. Nope. So, apologize for the shakiness here. All right, so first test first. Open up this knife, and you can see I can cut right into this rock, right? And I can do the same thing with the hammer actually too. You can scrape that rock fairly easily. Now it's white in color, for the most part white and gray, and you can actually see that there are layers to it, hopefully. I don't know if that's visible on the video, but these are old bedding planes, which would have been originally horizontal as layers built up over time. Right, so that's one thing to consider as well. We're certainly in sedimentary rocks. Now, there are lots of types of sedimentary rock that are fairly soft, and we've learned that some of them will react with hydrochloric acid, and if I put some acid on that piece right there, there's absolutely no reaction. So hopefully that's helped you narrow down your potential rock types. So as I back up so you can get a good view of the whole thing again, a reminder that folding like this is taking the form of what we would call ductile deformation, meaning that it can bend. And that's a lot easier in softer rocks than it is in harder rocks. So figure out what type of rock that is, and that'll help explain why it folded as opposed to faulting. All right, we're in the Carmel Formation still. These are the same rock types as the previous video. And again, that relatively soft rock here has been folded, and you can see that it's making a syn form. So we can't say that it's a syncline for sure, unless we know which way is up. In this case, it almost certainly is a syncline. You can also maybe see, let's see if I can point to this. Sorry about the shakiness there. If you look up there across that surface, that's a surface of erosion that has truncated that, and there might also be some faulting in there. I don't know, but that would be pretty low angle fault. Anyway, another example of very, very folded Carmel Formation, and we'll see a few more.